We're looking at compound interest problems here. So this example looks at finding the new amount. So we have the formula here, which says original amount times the multiplier, the decimal multiplier, to the power of years or months, whatever that n may be, is equal to the new amount. This question focuses on finding the new amount. So in this question, it reads, Jack has £15,000 to invest in a savings account for 3 years. And he finds information about 2 savings accounts, and Jack wants to have as much money as possible in his saving account at the end of the 3 years. Which of the 2 savings account should he choose? So let's first of all take a look at splitting this page up into 2 parts. So we've got the simple, and then we'll look at the compound here. So simple interest is where the interest is added on to the original amount at the beginning, same amount each year. So first of all, we've got 15,000 is the original amount. And if we want to increase this by 2.3% each year, we're essentially finding out what 2.3% of 15,000 is. So to find 2.3% of this amount, we can times it by the decimal multiplier or decimal. So 2.3% is equal to 0.023%, and that's by doing 2.3% dividing it by 100, and that turns it into a decimal. So then we've got this value of 0.023. So if we times it by 0.023, we'll know what 2.3% of £15,000 is. So 15,000 times 0.023, and that gets us £345. So £345 is the simple interest. The difference between simple and compound interest is that simple interest, this amount of £345 is the same amount added on each year. So now, since this is for 3 years, all we'll do is we'll do £345 times by 3 because of the 3 years. It's added on the same amount, and that gets us £1,035. And so how much we'll have at the end of the 3 years will be £15,000 originally plus the 1,035. And so if we add that, that gets us £16,035 at the end of the 3 years. Now, compound interest is where the interest is added on to the new amount each year. So in order to work out the compound interest, we need to work out something called the multiplier, i.e. the number, the decimal number that we multiply by in order to do a percentage increase or decrease. In this case, since it is compound interest of 2.15% each year, we'll first of all write down interest is added on, so it will be 100% add 2.15%. Okay, if the question was decrease or depreciate, we would do 100% minus that. So that gets us 102.15%. We then need to turn this into a decimal multiplier. And to turn it into a decimal multiplier, so here I'll write down multiplier, is equal to 102.15% divided by the 100 to turn it into a decimal multiplier. And that gets us 1.0215 as a decimal multiplier. This is our multiplier in our equation. So now we can go to our equation and we can go and write down original amount, which is 15,000. Okay, so we're using this equation here. Original amount times multiplier, which is 1.0215, to the power of n, where n represents the number of years or months, however the interest is added on. So here interest is added on every year. So it's to the power of 3, since we've got 3 years here. And that will give us what the new amount is. So if we go and type that into our calculator, 15,000 times 1.0215 to the power of 3, that gets us an answer of 15988.45 to 2 decimal places, since we're working with money. So from here we can see that we actually end up with less here from the compound interest for the 3 years, whereas the simple interest gets us more. So the question says, Jack wants to have as much money as possible in his saving account at the end of the 3 years. Which of the two savings accounts should he choose? Choose simple. Okay, so choose simple here.